Hi guys, Buildzoid here, and we're doing another one of these reacting to RAM timings videos. It's been a month since the last one, and I don't really want to do them more than once a month, because I think it would get very boring, because already I get a lot of copy-pasted Ryzen settings, and so, yeah. Anyway, the format is simple. You post your screenshots of your memory timings to Twitter whenever I decide to make a tweet about, hey, I need memory timings to look at, and then I look at memory timing screenshots until the video is roughly like 50 minutes long, because, yeah, I don't really feel like shooting a video for more than an hour. Anyway, let's get into it. Starting off with QXE's memory, like DDR5 overclock on the Z690 Dark Kingpin board. So we're looking at 6800 megabits per second, 30, 39, 39, 28, 1T. This is SK Hynix memory chips, TRRD SG of 8, TRRD DG of 4. The SG is basically as low, like, I could probably do 7, maybe 6, but DG of 4, that's as low as that goes. TRFC 360, that's basically as low as it goes. TREFI of 1, 2, 3, 4, 5, 6. I've not tested TREFIs above 65,000 for stability, but evidently this is at least passing mem test, so yeah. And like, yeah, like this. If this works for you, that's great. If it doesn't, then that, you know, don't use it. But personally, I prefer to keep the TREFI. Like, the thing is, going from 60,000 to 120,000 is actually a big improvement. Well, it's a bigger improvement than adjusting almost any other timing once you're at the point where, you know, like TREF, like after you've dialed everything else, and adjusting your TREFI like that makes more of a difference than pretty much anything else. At the same time, if your TREFI is too high, you might end up getting like data corruption out of nowhere. And also with, which on DDR5 might be less of an issue than on DDR4, because DDR5 very specifically has error correction for like data retention problems. Yeah, you might find that like erratic performance behavior potentially, because with the if the refresh interval's too long and you start having the on-die error correction fixing bits going missing, yeah, that's going to be bad. So I'm like probably fine. I don't know. I've not really like the thing is, refresh interval is annoying to test, because you do need to check it across a like large variety of operating conditions and that kind of thing. But anyway, like performance-wise, it's good. Like basically performance-wise, you want your TREFI to be as high as possible, assuming that there isn't any data retention issues. So anyway, TWR16, it's fine. I mean, it can be lower. RTP12, that's probably not going to go any lower than that. TFAW16, that's as low as it goes. TCKE4, that's as low as it goes. TCWL28, that's as low as it goes. Well, yeah, that's basically as low as it'll go. TRRDSG11, that's as low as that goes. TRRDDG, we're at 8, which is a bit loose. On a lot of setups, you can do 7, but the difference in performance between 8 and 7 is basically irrelevant. Read to write same group and read to write different group at 19, which is why you can run the why TCWL is a 28, because basically this is one of the few like timing relationships that actually affects stability, is the read to write timings and your write cast latency. You can run, like, potentially what should work is TCWL 30 with these at 17, or what you see here, which is TCWL at 28 with these at 19. So you can sort of trade those two for each other. Then for the write timings, well, the write to write, same group, different group, we have 9.7. Those don't go any lower than that. Write to read, we're looking at 56 and 44, and that's basic. Actually, that is as low as they go. That is very, very tight for those two. And then we have TWR pre is kind of loose. All the different rank and different DIMM timings are set to 1 because they do not apply in this memory configuration. Yeah, TWR pre and TWR PDEN are, yeah, they're kind of loose, which also like is reflected by the TWR of 16. But yeah, honestly, for DDR5, this is very solid settings. So if you have a Z690 Dark Kingpin and you want inspiration for your SK Hynix memory DIMMs, this right here is definitely worth considering. Though not all DIMMs will be able to do TRCD39. That's sort of the biggest difference I've noticed between the various SK Hynix kits I have. Like, I have one kit that just doesn't train low TRCD, and I have no idea why. But anyway, yeah, so great timings here, and let's move on to the next set of timings. So, from Ryan, Mr. Freak, we have used this for Minecraft-related testing, retired it unfortunately in favor of Alder Lake because single-threaded performance is more important than everything, especially for something like Minecraft. I will admit this took probably a week to actually configure and stabilize. Also, the power draw was insane, 900 watts in Y-Cruncher, because this right here is X299. This is 9980XE on a Prime X299 Deluxe 2 board. Doing 4000 CL14 on 64 gigs of Samsung B die. So we have, 8 sticks, dual rank, quad channel with dual rank. And the end result of this is just stupid memory bandwidth, 130 gigabytes per second, along with reads of 130 gigabytes per second, writes of 117 gigabytes per second, and copy of 116 gigabytes per second. The latency is kind of like for a DDR4, for a pre-12th gen DDR4 memory, man, this is so awkward because the thing is, the latency number in IDA doesn't measure the latency of the memory. It measures the total latency from the memory to the CPU cores. And so, depending on what connects the cores to the memory controller, you actually get very different latency numbers. So, like on, say, a regular Skylake CPU, 45 nanoseconds is actually kind of terrible. For an X299 CPU, or more like a Skylake X CPU, 45.7 nanoseconds is actually good because the mesh interconnect, which I consider I like to call it the mess because the latency of it is terrible. It's clocked really low. Yeah, it basically drags down the latency. So yeah, 45.7 nanoseconds, like in the grand scheme of DDR4 memory controllers, this is kind of terrible, but as far as Skylake X goes, this is actually really good. So yeah, this is basically the limits of what X299 can do. Especially for dual rank, a lot of the Skylake X memory controllers basically, like 4000, actually there's a lot of boards that won't even reliably do 4000 on single rank, so this is really impressive. Though it does help that, as far as I know, the X299 Asus boards are T-topology, if I'm not mistaken, so that certainly helps with running a, 8 DIMM configuration like this. Anyway, for the actual timings, 14, 14, 13s, that's as low as that goes. TRAS of 21, because X299 has a lower limit, like the limit for the register for TRAS is lower, as far as I know. Because the X299 memory controller is actually completely different from what you get on all of the other DDR4 Intel CPUs from that time period. Command rate 1, this is another one of the big advantages of the sort of Skylake X memory controller. It does 1T command rate basically always. I kind of suspect this is probably because this memory controller is designed for like server memory configurations where you can go up to absolutely stupid like numbers of memory ranks. And so the memory controller is actually just sort of better at driving the command address bus, and so yeah, like 1T command rate on X299 is generally not an issue, whereas on like Z390 and Z370 and like Z270, Z490, Z590, it really depends on the motherboard whether or not 1T command rate will work properly. Anyway, TWR10, that's as low as it goes. TRFC 231, that's basically as low as it, like, that's a very low TRFC. TRRDs of 4.4, though they don't go any lower than that. WTI, those don't exist. RTP6, it doesn't get better than that. TFAW 16 doesn't get better than that. TCWL 13, that's as low as that goes. The RTL timings actually look kind of optimized. They're a bit all over the place, but with this many memory sticks, I mean, what else do you expect? TREFI completely maxed out. This is actually probably the one downside to the Skylake X memory controller is the TREFI register only goes to 32,000 instead of 65,000. Yeah, anyway, TCKE 10, I'm surprised that that's not at 4, but it probably, like, it doesn't really make that much of a difference to the performance. TCCD 4, 8, yeah, so that's as low as those go. Well, actually, I think 4, 7 works in a lot of scenarios, but this is a dual rank memory setup, so that might be limiting how low the CCD timings can be. Why do we have TRRDs repeated over here? Man, ASRock timing configurator being weird. And then we have read to read 1, write to right. Man, the tertiary timings on the Skylake X memory controller are very different, and I'm looking at this and I'm realizing I have no idea what these are. So that's great. Like everything, the timings I recognize, those look great. The tertiaries is like, I don't know how to read this, so I'm not going to comment on that. But the fact, like, this is just stupid amounts of memory bandwidth. Yeah, like, DDR5 still doesn't reach this. Admittedly, that's, you know, dual channel DDR5, but, yeah. If we had a HEDT DDR5, like quad channel DDR5 setups, we'd be probably looking at around 200 gigabytes per second for reads, which would be really cool, assuming that the motherboards didn't suck. Anyway, yeah, so if you have an X299 setup, this is kind of the limits of what's possible for in terms of like stable overclocks. And also, yeah, with a memory setup like this, why Cruncher pulling 900 watts is very unsurprising, because that is a 9980XE. I kind of wonder what like gigaflops this gets in Linpack. Like this has to be insane for Linpack, because the memory throughput on this has to be ridiculous. Anyway, moving on to the next set of timings, we've got Snuta with a Prime Z690-P Wi-Fi D4 motherboard doing 4000, 1415, 1434 2T. So this is going to be Gear 1, dual rank Samsung B die. So primaries are pretty much like standard for Asus boards. TRCD, because this is my current daily, can't be fucked to tighten the TRCD because 1.55 volts and beyond doesn't post. That is rather surprising, because as far as I know, that is mainly a Gigabyte motherboard problem in my experience. So very interesting that that's occurring on an Asus board. But the thing is, the TRCD on 12th gen just doesn't really seem to go very low. Like, I recently worked with a setup where you could push the TRCD all the way down to like 12 and still run benchmarks, but you couldn't pass any stress tests until you raised it all the way back up to 15. Which is kind of ridiculous. Like, you would think if you can boot and like run benchmarks with a TRCD of 12 or 13 or 14, right? Like, something like 13, 14 should be like stable for memory stresses, but no, you need to go all the way up to 15. So yeah, it seems to just be some kind of weird, like, I wish I had a larger sample size of 12th gen CPUs and dual rank B-die memory kits, but I have a sneaking suspicion that the 12th gen memory controller just really doesn't like to do low TRCD like once you go past like 3866 or something. So yeah, like, I'm pretty sure even if you gave it 1.6 volts and 1.5 volts system agent, or even 1.45, like, what more system agent voltage, I don't think that TRCD would improve. I really don't think it would change anything. I think it would stay at 15. Anyway, what else do we have? So yeah, so the primaries are pretty standard dual rank B-die stuff for Z690. Then we've got 10, 280. TRFC per bank isn't used on DDR4. We've got 6.4 for our TRRDs, so that's like good. TFAW 16 good. RTP of 6, that's as low as that generally goes. TCWL 14 good. The round trip latencies are correct. I've recently, like, one of the things to watch out for with probably with Z690, I'm not sure how much of a problem it was on the thing is, I generally stop pretty early on the memory speed, because the memory controller gets very upset. Like, speed is generally more taxing on the memory controller than timings. Like, you can do low timings pretty much for free. Like, timings pretty much don't care, whereas the memory speed is very much like that's the difficult one. And so I generally, like, if I'm struggling to boot a certain memory speed, that's like the first thing I'm willing to give up on, because if it's struggling to boot it, then it's probably not going to be stable. But anyway, so one of the things to watch out for on Intel systems is if you're at a memory speed where your RTLs, just like one of them is way off from the other. So like 71, 71, 73, 73, these are pretty close together, so that's good. But you might end up sometimes where you'll have like 71, 71, and then these two will be like 83 or something ridiculous like that. And that's a sign that you should probably back off the memory speed, because the memory controller can't figure out the delay between itself and one of the memory sticks. And that actually significantly harms the memory latency. So, yeah, anyway, then for TREFI, we have 42069, nice. TCKE of 8, it could be lower, but TCKE doesn't really make that much of a difference to performance. Then we have 7477, so yeah, well, 7477, 12, 12, 12, 12, 12, 26, 24. Why are these 11? Like, I'd expect these to be like 9 or 7s. I'm really surprised that these are at 11, but okay. And then we have 7477. So basically, like, other than the two 11s over here, the tertiaries are good. Like, this is what you're aiming for dual rank Samsung B-Die for Z690. Not really much more to it than that, but I am very, like, those 11s are weird. I'm kind of, yeah, I'm not sure about why those 11s are there. Like, I would really expect those two to go lower. Anyway, let's take a look at the next set of timings. We've got Skelly Dog with Ripjaw's dual rank on Ryzen 3700X on an X570 Plus TUF, so Asus board. And we're looking at 14, 15, 16, 15, 28. So yeah, pretty standard dual rank B-Die timings for the primaries. Not the strongest kit ever, apparently, because that TRCD is relatively loose. Though it could also, like, TRCD could also be kind of affected by the motherboard. TRC42, which makes sense. Could probably go lower, actually. Yeah, like, I'd probably try to push the TRAS and the TRC a bit lower. Like, TRAS 28, like, if I'm not mistaken, the Ryzen memory controller has a minimum set, like, the minimum setting for TRAS is 21. So you could theoretically run something like 15, 21, and then 36 for your TRC. The TRC 36 would probably be pushing it. TRDs of 4.4, that's good. TFAW 17 is a bit weird. I'd be really surprised if the different, like, the ability, like, yeah, I'd be very surprised if this being stable was dependent on, like, 16 versus 17 of TFAW. This isn't, yeah, like, it also probably doesn't really make much of a performance difference at all, because this is literally just tacking on one extra cycle after every 4 activate timings. So that's not really, like, performance-wise, it's not a big deal. I'm just surprised that, like, I'd be very surprised if that was actually necessary for stability, is what I'm trying to say. WTRS 4, good. WTRL 8, good. These generally don't go any lower than that. TWR 12 is a bit high. Like, usually you see it at 10, but 12 is also perfectly acceptable, and it won't really make much of a performance difference. TRFC 250, which is a relatively low TRFC. My main complaint here are these two, the SCLs. 5.5, like, I've literally never run into a system where 4.4 doesn't work, and on a lot of setups, you are able to run 2.2. So 5.5 to me is kind of like, no, this is bad. This looks like you forgot to set them. I refuse to believe that this is the minimum SCL timing that this is able to run. This looks like you just kind of forgot to set those two. TCKE of 1, yep, that makes sense. Like, that's as low as that goes. RTP 8, that's general. 6 sometimes works. And then the tertiaries look fine at a glance. It's been a while since I've messed with tertiaries on Ryzen systems. But yeah, all around, like, for a daily setup, I wouldn't worry about tweaking this any further, though I really would set the SCLs down to 4. Like, I refuse to believe that they have to be at 5. That doesn't make any sense. I wouldn't bother with the TFAW. Like, I'm pretty sure 16 should, like, if 17 works, 16 really should work as well, but there the difference isn't as large as like the latency improvement that you would get from lowering these two. Runs rather hot. The heat spreader, yeah, that's the one downside to the Ripjaws 5 kits from G.Skill. Like, they're really great way to get like high memory bins in for a low price, but the heat spreaders that they come with are terrible. Absolutely terrible. Not sure if better cooling and or more voltage would allow better timings. This is what voltage is it at? Oh, we don't know what voltage it's at. I'd say more cooling. Apply fan directly to memory. That generally helps a lot, especially for something like TRCD. Next set of timings, we have Duthi with a 2600X. Wait, why did I include this? I feel like this tweet got changed. Because I remember looking at similar timings to this, but there was a very long explanation behind them. Anyway, we can still take a look at these as they are. So yeah, we've got 3333s, it's a 2600X, 16 gigs of memory, so that, like, this is Samsung B-Die because we're looking at flat 14s for the primaries. The SCLs are at 2, so those don't go any lower than that. 14 at 8, so TC, yeah, those are fine. So the thing is here, TRAS 28, that might go lower. TRC 44, kind of high. And then the TRRDs, which are 6936, which is terrible. Like 4416. Because for a lot of workloads that are memory throughput limited, going from like 6936 to 4416 will make a bigger performance difference than pretty much any other memory timing adjustment you can make. So yeah, I would really highly recommend that gets switched over to 4416. WTRs of 412. The 12 can probably be an 8, but 412, like that looks fine. Overall, TWR10, that's fine. TRFC 267, that's a reasonable TRFC for Samsung B-Die. And then a TCKE of 9, I'm pretty sure it could do it, you could set it to 1. I'm pretty sure you can set it to 1 and it'll be just fine. Yeah, but since this is a 2600X, there's a pretty decent chance that it's just not going to go any higher memory speed than 3333. So, yeah. Well, maybe with more SoC voltage, like 1.15 volts. For the 2000 series and the 1000 series, I generally just go straight to 1.15 volts of SoC voltage because the sweet spot is generally somewhere between 1.1 and 1.2, so 1.15 generally gets very close to it. The thing is, like, that still doesn't guarantee that you would be able to do 3400 even. But it would be, like, if you want to mess with that, you could try that. Alternatively, well, you have gear down mode disabled, right? Like, GDM is disabled and it's on 1T command rate. So alternatively, since GDM is disabled, you could shove more voltage into it and see if you can do, like, 14, 13, 13, 13. Like, yeah, just 14, 13, 13, 13. Or 13, 13, 13, 13. Or if the DIMMs are really good, or you're just willing to run a lot of memory voltage, you might be able to do like 12, 13, 13, 13, 13, maybe even flat 12s. You might actually be able to set all of the primaries to like 12, 12, 12, 12, 12. At that point, I would suspect you would probably need like 1.6 volts of memory voltage on a lot of kits, but it might be doable. Anyway, though TRCD might get stuck. TRCD might get stuck at, and by TRCD I mean TRCD-RD, that might get stuck at 12. I mean, stuck at 14 or 13. Yeah. Anyway, so really the only complaint, like my main complaint for this right here is the TRRDs. Like the 6936, like also the 36, like 6936, like the 36 functionally turns that 6 into another 9. Because what's going to happen is you're going to have a 6, like, because that's your 4 activate window. And so that basically limits the shortest amount of time that can be spent on doing 4 activates. So when you have your short activate takes 6 cycles and your long activate takes 9 cycles, well, if you do 4 long activates, they're going to take 36 cycles to do. But if you do 4 short activates, they're going to take 24 cycles to do, and your 4 activate window is set to 36. So after your 24, after your 24 cycles doing 4 short activates, you're going to have a 12 cycle delay to bring it up to 36. So basically, this functionally is pretty much the same as if you had like 9936. There's actually a little bit of overhead from having the TRRD set. Like 9936 would actually be very slightly slower than 6936, but not like, screw that. This should be like 4416 or 4616. 6936 is just bad, especially for Samsung BDI. So anyway, moving on, we have Jack O'Neill with a, what is this? We've got some kind of, we have a 10900 KF on a Maximus 12 Apex, great motherboard, straight up the best Z490 motherboard. Well, actually just in general, the best Z490 motherboard. Imagine if the Maximus Z690 Apex was as good as the Maximus 12 Apex was, straight, like right from the get-go. But anyway, so we've got dual rank Samsung BDI doing 4500, 16, 17, 17, 35 2T. So yeah, good primaries, like very high memory speed. So that's solid. Then TWR 12. I'm surprised that it's not 10, but 12 is just fine. TRFC 295. That's a weirdly specific TRFC value. Like, you just like leave it at 300. It's not gonna make a difference. Yeah, like, I don't know why you would lower your TRFC by 5 cycles. Like, this is just really not going to make much of a difference, but hey, like, it doesn't hurt anything. It's just weird. Like, for me, it's weird to see people have, like, super specific TRFCs. Anyway, the TRRDs, we're looking at 4.4, good. WTRs aren't real on Intel. RTP 8, good. Might do 6, but actually at this speed, it probably doesn't do 6. TFAW 16, it doesn't get any better than that. TCWL 15 really doesn't, yeah, like that's not going to get any lower either. RTLs look like they're actually optimized, because that is 6162 with 6.6, so that is, yeah, that's some solid RTLs right there. I really wish we had a latency measurement for this setup, because this is, if I had to guess, this is like well below 40 nanoseconds. Yeah, this should be well below 40 nanoseconds. This is probably like I want to say it's like mid 30s or less. It should be below mid 30s. Anyway, TREFI we have 65,000, TCKE 6. I am surprised that's not a 4, but a 6 and 4 aren't really that different. SG 645. Man, these tertiaries are very tight. 645, like it's not, there's no way it's getting lower than that. Then we have 10, 10, 10. Yeah, that's just extremely tight. Then 28, 24. It's a little bit on the loose. Like, compared to the other tertiaries so far, these are actually kind of loose. Like, this is what I like to use, because 28, 24 almost always works, whereas something like 26, 22, or like 26, 24, or 26, 23, like, there's a few different values you can try. But basically, below 28, 24, there's a decent chance it might not work, whereas 28, 24 is pretty much guaranteed to work. But yeah, so still, like, it's not really going to make a performance difference, and so that makes sense. Like, the thing is, when you have a 2-digit value and you change it by like 1 tick, it really doesn't matter as much as when you have a single digit value and you change it by 1, right? Going from 7 to 6, big deal. Going from 27 to 26, not a big deal. In fact, basically the same thing. Anyway, then different rank is at 6, so yeah, that's properly tight as well. And then we have 7, 4, 7. Like this, right? If you've got a Maximus if you've got a Maximus 12 Apex and you've got BDI on it, like, this is goals right here. This right here is goals. Especially since this isn't even at like insane memory speeds, because a lot of 10th gen CPUs, like, they will really struggle above like 4,500 megabits per second. You're like, my 10900K, in order to just like boot 4,800 megabits per second, needs absolutely ludicrous amounts of system agent voltage, especially on Samsung BDI. And so yeah, this right here, this actually, like, this is, like, sensible memory speeds, sensible primary timings, like, I mean, this is still good. CL16 at 4500, not like some kits will need quite a lot of voltage to hit that, but yeah, this looks good. This looks really good. I like this. So yeah, and this is at 1.585. Yeah, so that's the thing. Those primaries, like if you backed off the memory voltage a bit, like basically the only thing that would suffer would be the primaries. Like I think at 1.5 instead of 16, 17, 17, it would end up being like 17, 18, 18. Oh, and TCWL would probably have to come up from 15 to 16, but yeah, really good. And like the tertiaries, like these are great. These are just really, really good. So yeah, good job, Jack O'Neill on these memory settings, because yeah, they're great. Anyway, moving on to the next set of timings, we've got a ROG Strix Z690-A Gaming Wi-Fi D4 doing the generic Z690 memory settings for dual. Wait, what? Oh, 4 sticks instead of 2 sticks. Okay, so that's actually quite a bit different. So this is cool to see because I've not done much 4-stick testing with Z690, and so it's nice to see what's possible. Yeah, and we're looking at 4000, 15, 15, 15. TRAS 30, command rate 2, so primaries look good. I'm surprised, like, I'd set the TRAS to 28. Like, it doesn't really make a performance difference, but I just set it to as low as it goes, because, like, with BDI specifically, it never really causes any issues to just set as low as you can, but, well, whatever. Command rate 2, I mean, it's a dual rank setup, so there's basically no way that it's running command rate 1. Write recovery, we're looking at 12, that's fine. TRFC 300, yep. TRRDs 4.4, yep. RTP 8, yep. TFAW 16, TCWL 14. Standard BDI secondary timings right there. RTLs look good as well, since we have 6971 and 7171. So it doesn't, like, it's not missing memory training or anything like that. TREFI of 65,000. TCKE2 doesn't work. I'm pretty sure that's getting rounded up to 4 by the memory controller, because if I remember the Intel documentation correctly, the TCKE timing register literally doesn't go below 4. Motherboards will let you punch in values as low as 1, but yeah, the memory controller doesn't accept values of less than 4 as far as I know. So I'm pretty sure this is actually getting corrected to 4 on the memory controller itself. And then for the rest of the tertiary timings, we've got 8, 4, 8, 8, 12, 12, 12, 28, 24, 8, 8, yeah, just 8, yeah, and then 8, 8, 8, 4, 8. So this is what I would consider like the super safe tertiaries for BDI of like 8, 4, 8, 8. Alternatively, if you want to like push the performance a bit further, there's the option to do like 7, 4, 7, 7. Leave the 12s alone, leave the 28, 24 alone, then 7, 7, 7, 4, 7, 7. Yeah, but if you don't really, like, if you don't want to, like, going from 8 to 7 is probably not going to make that much of a difference. It mostly affects your memory bandwidth. But yeah, like, this is good. This is very solid for a daily setup. I wish we knew what voltages this was at, but I like it. Yeah, this, you know, I'd consider the tertiaries kind of relaxed, but this is still a lot I'm pretty sure this is still better than what you would get on auto settings on a lot of motherboards. I'm not sure if the Strix might not come with some, actually, I don't think Asus does that. I think that's literally just an EVGA thing because it's generally a bad idea. But on EVGA boards, if you use Samsung memory sticks, it'll preload Samsung BDI tertiary timings, which is very awkward if you're using something like Samsung CDI or Samsung DDI or literally anything that isn't BDI because it doesn't work. But anyway. Yeah, this is just a very solid daily Z690 setup as far as I'm concerned. And I mean, the only adjustment I would try to make to this really is, you know, see if the tertiaries can do 7s where all of the 8s are. It is also worth noting that this is a, you know, dual rank, dual channel setup with 4 separate memory sticks. So technically speaking, the DR timings, those don't apply. So like RD, DR 8, like this isn't actually being used by the memory controller because the memory controller, like DD is different DIMM and DR is a different rank on the same memory stick. But we have 4 memory sticks here, so it's only using the different DIMM timings. It's not using the different rank timings. Yeah, that's just kind of like the thing is, if you set your timings in like this pattern where you just go like 7 4 7 7, and you don't worry about the distinction between different rank, different DIMM, and you just set your different rank and different DIMM timings to the same value always, you don't really have to concern yourself with that. So, yeah. Anyway, basically I would just try to set all of the like see if you can set any of the 8s to 7s, because that would help memory bandwidth a bit. But other than that, solid. So yeah, let's move on to the next timings. How much time do we have? Oh, not that much. Please go. We have Blair Durkee. I've probably butchered that name. Please go easy. I went for daily stability over maximum OC. Kit is a G-Skill F4 4000 C18D 4x8 running 1.45 volts. That's the correct memory kit to use on a Z390 gigabyte motherboard, since those are all T-topology boards. So you want to populate all of the DIMM slots, because otherwise you have termination issues on the unpopulated side of the memory channel. And anyway, in terms of settings, we're looking at, what is it? 1.45 volts. Okay, so like a sort of sensible memory voltage rather than really pushing it. And we're looking at 4,000 megabits per second, 16, 17, 17, 32, 2T. Yep, so standard for dual rank. Z390. I'm surprised. Well, I mean, at 1.45 volts, I guess it makes sense. And also, depending on the CPU, pushing past 4,000 megabits per second might require kind of a lot of system agent voltage. Secondaries, we're looking at 10350 is weird. I'm generally pretty forgiving on TRFC, but this is BDI. Set your TRFC to 300. I refuse to believe that it actually has to be at 350. Like, even my cheapest eBay memory sticks do 300. And by that I'm referring to a 3200 CL16 Samsung BDI kit that I have, and even that'll do 300 TRFC. So 350 just doesn't make any sense. TRRDs, we've got 6.4. Oh, that's like 6.4 is for DDR4 is like, I've never seen a set, well, for BDI. Other memory ICs, it depends, but for BDI, 6.4 pretty much always works, whereas 4.4 can be sometimes not, like sometimes might not work, so 6.4 is like the safe way of doing things. WTRs aren't real. RTP is 8, which I don't think it would, like, it might do 6, but, you know, we're going for stability here, so leaving it at 8, it's just fine. TFOS 16. And what I mean by that is I personally wouldn't really feel like spending the time running a stress test just to run my RTP at 6 instead of 8. If I know it's stable at 8, I'd just leave it at 8. TFOS 16, TFOS doesn't go lower than 16. Cast write latency, we're at 14, that's good. The RTLs and IOLs are kind of terrible, to be completely honest, but the thing is, I don't have a suggestion for how to fix them, because while I did eventually, like, somebody eventually explained to me how to set RTLs on gigabyte motherboards on a Z590 motherboard, I have no idea if that method also works on Z390 motherboards. And I said, you know, the annoying thing is, like, I said I'd make a video about it, but at this point, like, DDR4, like, Z390 and Z490 and Z590 motherboards aren't really relevant, so it's like, you know, the motivation to make that video is kind of gone, even though it's like useful information. And I do kind of want to know if that method that worked on the Z590 board would also work on a Z390 board. Because basically dialing in the RTLs and IOLs would significantly reduce the memory latency. Like, you can shave off quite a few nanoseconds. Admittedly, it depends if you can actually push the IOLs and RTLs low. Not all CPUs and not all memory setups will be able to run them super low. Yeah, like the default settings on gigabyte motherboards, once you go past like 3600, the RTLs get very loose. And that does cost you some memory latency as well as memory bandwidth, because yeah, like you can't really have, we're not going to get into that. TREFI at 65,000, that's as high as that register goes on Z390 or yeah, Z390 compatible CPUs. TCKE of 1. I'm pretty sure it doesn't go below 4, but again, the memory controller, I'm pretty sure it just corrects for you if you try to run it below what it's able to do. And then the tertiary timings, we're looking at 7, 4, 6. And this is where the different rank, different dim distinction actually becomes kind of significant. That 6 in this configuration doesn't do anything. Yeah, because this is a different dim situation. This isn't a different rank situation. Like, this is technically dual channel, dual rank, right? Because we've got 2 ranks of memory on each memory channel. But the memory controller has 2 separate timings for a memory rank located on the same memory stick and a memory rank located on a different memory stick. And the timing used for a rank of memory on a different memory stick is the DD timing. It's not the DR timing. So 7, 4, 6, 8, that 6 shouldn't be in use. If I'm not mistaken, the 11th gen CPUs actually had these 2 memory timings swapped around, which is super awkward, but yeah, I'm pretty sure that 6 shouldn't be doing anything, and you'd actually want to try lower your DD timing. So like 7, 4, 6, like I'd be trying to do like 7, 4, whatever, 7, or 7, 4, 6, 6 maybe? I don't know. Like the DR timing doesn't matter. Anyway, for the read to writes, we've got just straight 16s, which, yep, that's cool. WR write to reads, we've got 26, 23, good. Different rank in DD are at 9. I kind of think 8 would probably work. 7 might also work. And then we've got 7499, and again, I'd be surprised if like 7488 or 7477 wouldn't work. So that would be worth trying, but honestly, the performance of this is probably fine. I mean, it's a dual rank setup doing 4,000 megabits per second. Depending on what you're doing with your daily system, I wouldn't really... Like, this is way faster than any XMP profile, as is, and so at this point, it's like minor adjustments that, like, you know, if you dial in if you tweak the tertiaries a bit, it'll get more memory bandwidth, and if you fiddle with the RTLs, you'll get a bit more memory bandwidth and slightly lower latency, but at this point, there's not really much room for improvement. Honestly, even going from like 350 TRFC to 300 TRFC isn't really going to change the performance that much at this point. So, yeah, while there is some sort of like general, especially the tertiaries are a bit on the loose side, and the RTLs are like, well, default RTLs for a Gigabyte Z390 motherboard. I don't think you'd see any drastic performance improvements by, you know, putting more time into this at this point. Anyway, unless of course you're doing competitive benchmarking, in which case literally 1 tick of any timing is the most important thing ever. Moving on, we've got Simon with some Ballistics Max at 1.5 volts on a 5700G, and man, I like, it's a real shame that the APUs don't come with more L3 cache, because well, they like their CPU performance due to the lack of L3 cache is kind of miserable, but the memory controller on them is basically cheating. Seriously, it's just so freaking strong. So yeah, we've got 4733 megabits per second. This is a single rank memory setup. I know it's 32 gigs of memory, but this is I'm assuming it's single rank, right? Yeah, 660, this is not going to be... yeah, that's M8FB... Wait, FB1. Yeah, so we're looking at 16 gigabit Rev B, so this is a single rank memory configuration. We've got gear down mode disabled, command rate 1T. That is a lot of SoC voltage. Then again, this isn't... Like, the thing is, the APUs are monolithic, so their SoC is not the same as the SoC that you get on your regular Ryzen chips. Though I'm not sure if that definitely translates into a higher SoC voltage tolerance. It probably does. Because, like, you know, because the thing is with, like, your regular Ryzen CPUs, you have a 7 nanometer CCD, and then the actual I/O die, which runs off of the SoC voltage. Well, that's built on, I think, 12 nanometer Global Foundries. Whereas the APUs are 7 nanometer everything. Or basically everything. So, yeah. And the thing is, I know for a fact that the SoC on the Ryzen CPUs starts to sort of disintegrate at like 1.4 to 1.5 volts in my experience. So even 1.3, I wouldn't be willing to run that long term. But with the APUs, I have no idea. I've never tested them at like super high SoC voltages, and they are made on a different manufacturing process, so they may very well be tolerant of much higher SoC voltages. Then again, if I remember correctly, I don't remember using a lot of SoC voltage for my 4750G, even at like absolutely ridiculous memory speeds. So, yeah, I'm not sure about that. That if it's stable for you and you're willing to take the risk, good for you. I personally would probably try to keep that below 1.2 volts, but it's your CPU. I'm not going to stop you. Anyway, as for the timing, 17, 21, 21, like it, Micron Rev B, so this looks good. TRC is kind of horrible because it's Micron Rev B. TRRD is 4416. This doesn't get better than that. WTRS, good WTRs, really nice. TWR12, I'm surprised that's not a 10, but honestly, it probably wouldn't make too much of a performance difference. TRFC of 660, that is the one downside to basically all Micron memory chip. Actually, basically, all of the smaller manufacturing process, like, basically most memory chips released after Samsung BDI have terrible TRFC. So yeah, though Rev B admittedly is one of the worst as far as TRFC goes. Like, it really needs it very, very loose. Like Hynix DJR will often do like, at this kind of speed, I'd be expecting DJR to be in the 500 range for TRFC, whereas with Micron, yeah, you're looking at like 660. So that's like technically it's not the lowest TRFC you could possibly run if you use better memory chips, but for this specific memory chip, yeah, that's basically as low as it goes. SCLs of 2.2, good. TCWL 16, good. Wait, what? Oh, right, RTP6, good. And the tertiaries look good as well. So, yeah, this just looks very solid. The only complaint I have is that SoC voltage looks a bit high, but I don't have any solid evidence that it's actually dangerous, so, that's on you. Yeah, anyway, moving on. I do want to get through a lot more of the timings. I feel like... Well, I think we're now getting to the like generic Ryzen memory setup, so we hopefully get to speed through the next couple. Because we don't have much time left, yeah. 3800, so this is what, a 5800X on a Strix B550F board. Gear down mode enabled, command rate is at 1T because it's in gear down mode, and we're at 14, 14, 14, 30, 44 TRC, okay, like... I'm surprised the TRAS isn't lower, but hey, that's completely fine. This is at 1.5 volts. TRFC and TWR not minimized. I mean, your TWR is at 12 instead of maybe 10. It's not really, like, I wouldn't put the effort in for that. Needs active cooling to pass MEM test. Yeah, because of your TRCD14, probably. I'm pretty, like, so the funny thing about the temperature stability, especially on BDI, like a lot of people would be like, oh, it's related to the refresh cycle, right? Definitely related to the refresh cycle. My experience with like messing with the hairdryer and overclocking BDI is that it's actually the primaries. The primaries are the thing that makes the temperature sensitivity go through the roof. So... yeah, I think, so, yeah, needs active cooling to pass MEM test, otherwise it hits 50C, like, yeah, I'm not really surprised. Arguably dual rank does make the thermal density of the memory sticks higher, as in, like, dual rank doesn't really change the temperature sensitivity, it just means, yeah, it's easier for the memory sticks to hit a high temperature. But other than that, like, the settings look good. Like, these are good memory settings, and the fact that it needs active cooling is like, well, you're running flat 14s at 3800, so that really isn't surprising. So, yeah, that's that. Moving on, we've got a Z490 setup with a 10850K and 32 gigs of Crucial Ballistics Micron Rev B. And VCCSA and VCCIO set to 1.2 volts. I tried, but I would appreciate the helpful roast. Okay, so this right here is not enough VCCSA generally. Like, when I work on sort of the, like, Z270, Z390, Z490, Z590, Actually, well, 11th gen, like, so I guess I should say like 7th gen to 9th gen Intel mainstream CPUs. I would start with VCCSA at 1.35 volts. Like, I would just not bother with any VCCSA lower than that, because 1.35 volts is perfectly safe. On a lot of CPUs, it's absolutely necessary for high memory speeds. And so there's really no reason to use less VCCSA than that, as far as I'm concerned. Like, there just isn't. Like, you know, you might feel good about having your memory voltage, like system agent voltage, perfectly optimized for your memory setup, but it's like, it doesn't actually make a difference. If it's stable, who cares? If it's stable, like, yeah, if it's stable and a safe voltage, who cares? So, yeah, that's kind of that. Now, the one issue I can, one problem with this is that, and not the setup itself, but me looking at the setup, is I have no idea how Asus motherboards deal with Micron Rev B. A lot of the sort of earlier Intel memory controllers don't really deal with the Micron memory chips particularly well. Like a lot of Z390 motherboards, if you try to put a like Micron Rev E into them, they'll get stuck at like 3600 because some of the settings, like, I've never really figured out what settings to adjust to fix that. But yeah, so I imagine Micron Rev B should be better about that, but I would assume that you're potentially running into that. I think what I would do with this setup is I'd probably loosen it out to like 18, 22, 22, 44. Yeah, 18, 22, 22, 44. Leave everything else on auto. Set 1.35 volts system agent VCCIO to 1.3. And then I'd see like I would hope that that would be able to boot like 4400 or something. It is a Z490 board. Yeah, I'd be aiming for like 4266, 4400. And after that, I would basically try to dial in the you know, all of the timings. I'd basically set like TREFI to 40,000 or 65,000. Like, again, with TREFI, like, well, like 40,000 is definitely safe. 65,000 might be safe. So, you know, good luck with, like, you know, you can test that yourself if you want to. TWR should be able to do, like, actually, I'm lazy, so I'd punch 12 into that. TRFC, I'd actually maybe, this is an Asus board, so it probably doesn't do this. MSI boards, if you use Micron memory sticks, will set your TRFC, for like Intel MSI motherboards, will set your TRFC to like 1,000 or something stupid like that. So on those, you have to set your TRFC, otherwise you're losing performance to that. But on Asus boards, I don't think they do that. So you might be able to get away with TRFC at auto, or you might be able to shave, I think, like 5-10% off of the refresh cycle. But yeah, not entirely sure. TRRDs, I would probably try 7.4 and 6.4. I've generally struggled with running 4.4/16 on running 4.4 on Micron memory sticks. So yeah, I'd probably start with like 7.4. WTR, we can ignore those. RTP, actually, I'd probably just leave it at 12. TFAW 16, of course. TCWL, if you were 18 TCL, I'd try TCWL at either 18 or 17. I don't know what to do about the RTLs. And for the tertiaries, I think initially when you're working it up, you'd be starting with like 8.4, 8. Actually, you don't have to worry about the DRDD timings. This is single rank. So yeah, you'd be like 8.4. 1818, I think, initially just to start, you should be able to work them down. And then for the write to read and write to read, so the two write to read timings, I'd be setting them probably to like 44 and 40 to start out, and then see how far you can push them down. Actually, I think I have a Z590 Dark with Micron Rev B on it. So I would try to take some inspiration from the timings I'm running there, is what I would do. Yeah, like I'd probably look at the timings that I used on the Z590 Dark and try to use those. The main concern is that the memory control, like I think it's a termination issue. Like it might, yeah, I'm pretty sure it's termination settings not being set correctly for Micron DIMMs on like early Intel memory controllers. But this is a Z490 board. I think if you use the latest BIOS or like a relatively like recent BIOS release for this board, I think it should have decent Micron compatibility. So yeah, that. But unfortunately, like, I don't actually have any real world hands-on experience with this. This is just kind of, how I would approach dealing with Micron on a Z490 Asus board based on my experience with Micron on a variety of other Intel boards. And it's at 3800, which is a pretty good sign, because normally if you have a major compatibility problem with an Intel memory controller, it gets stuck at 3600. And I don't know why it does why it's specifically 3600, but that's generally where the the default memory controller configuration seems to break down, like once you start going above that. Anyway, the video is now 55 minutes long, so I will end it here because the goal is to keep it under an hour. So yeah, that is it for this round of reacting to people's memory timings. And the next one will be in roughly a month, I guess. So, yeah, thank you to everybody who posted their timings. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the AHOC Teespring store where you can pick up like shirts and posters and hoodies, the usual YouTuber merch. And then I also have a Bandcamp for my sort of like industrial noise project thing. So if you'd like to check that out, there's a link to that down in the description below as well. And yeah, Patreon, Teespring, Bandcamp, all of them help out immensely with running the channel. So if you'd check them out, that would be much appreciated. And that is it for the video. So thank you for watching, and goodbye.